Let's start chapter 1.4, which is about one-sided limits. A good first question is, why should we care? It's partly a build-up to chapter 1.5, and they're also interesting in relation to some common waveforms. We all know sine waves and cosine waves, but there are other kinds of waves. There's ones called triangle waves that have the same slope going down and then going up, even though I didn't draw it very well here. There's something called a square wave. You can imagine why. Now this, the way I've drawn it isn't technically a function because it doesn't pass the vertical line test, right? What it really is something like this, where it's constant and then it instantaneously switches to some other constant and then instantaneously drops back, which is a good trick to be instantaneous in the real world, but at least that's how we imagine it mathematically. There's also something called a Sawtooth function. Here I've got an increasing sawtooth. You could also have a decreasing sawtooth. And again, as I've drawn it, it's not an actual function because it doesn't pass the vertical line test. So what it really is mathematically is a ramp up and then an instantaneous drop down, and repeat that, or it could be a ramp down and then jump up. There's also interesting waveforms called a half rectified sine wave, where if the sine wave would be negative, you just count it as 0. That's like running it through a one-way valve where it only allows the positive values. Or a full rectified sine wave, where even when the sine wave would be negative, you count it as positive, which would be taking the absolute value. Let's go take a listen to all these real quick. Here we are in one of my favorite free apps on the web called the Falstad Fourier App. I'll put a link to it in the video description. So let's listen to a sine wave. Hopefully this won't be too loud, but watch your headphones just in case. So that's a sine wave. Let's listen to a cosine wave. Pretty much the same. Let's try a triangle wave. Has a bit of a different, almost musical instrument sound to it. Let's try a square wave. That's even more harsh, I would say. And then sawtooth. It's harsh in a different way, maybe. And then let's go back to sine, but then we're gonna half rectify it, basically counting the negative parts as 0, and then try fully rectifying it. So there's the sine, and we'll half rectify. So again, sine, and then full rectify. So that was interesting. It sounded twice as high, right? There's all sorts of interesting things to say about like taking a square wave and approximating it with sine waves. And that's the essence of Fourier analysis, and I'm making videos about that too, but let me just include it here because it's fun. So let's see. Here's approximating a square wave with a single sine wave, and then we'll add more. Square, and then you can see it's getting to be a better approximation, and the sound is changing too. All right, let's go back to limits in the next video.